Good morning, everyone. Welcome to your geometry class online. This is sort of what a class is going to look like. In this video, we're going to do 10-1. How it's going to work is I have some sheets of paper in front of me, I have a whole thing of markers, and I have these slides as well. For example, this is our alternate view. All I'm going to do is try to make this just like what we do in class. So I'm going to go through these slides. These are straight from Schoology. They're not edited at all like I normally do. I normally have them. We're going to take them straight from Schoology. So if you're on your computer, if you're on your phone, you can sort of follow along there. If we get to a problem where I want to kind of go deeper into it, I'll write it on the paper and we'll solve it out together. But we're going to go through chapter 10 this way until we are out of quarantine, basically. So with that being said, let's get started. If you have any questions, I will have office hours, and during different school scheduled times we can talk. So there'll be plenty of time for you to find me and get all of your questions answered. So with that being said, let's move on. So this is 10-1. We have these sort of intro questions. We can skip these. Maybe we'll find one that we like. Yeah, we'll skip all these and we'll go straight to the beginning of the notes. So there's a lot of preamble in these slides, lots of things we don't actually need. So we will move through them pretty quickly before every section. We have vocabulary. These are things we're going to talk about: circle, radius, chords, diameters. We actually did this lesson before back in school, but I'll do it all again as if we haven't. So those of you who don't remember pre-spring break, what that was like, we can have a fresh start. For example, we have these different names. We have radius, chord, and diameter. A radius is a segment with endpoints at the end of the circle. A chord is a segment with endpoints. Radius is a segment with endpoints at the center of the circle, and the other one is a endpoints on the circle, and the diameter is a chord that will pass through the radius. So let me give you one quick thing. We have a circle. That's not the best one, but we have a center. We can call this circle circle C. So this is circle C. We have a radius. We'll go from the center out to the end. That is our radius. We can have a chord. A chord is going to go from one part of the circle to another, but it's not going to go, it could go through the center. So this is a chord. And finally, like a diameter. So diameter is going to go through the center, and it's going to go end to end. It can go any part of the circle, something like this. So we have circle C. We could write that a couple different ways. I could call this, or I can do this symbol, circle C. So really the first part of this lesson is just talking about sort of our vocab. So back to the slides, you have these things. If you need to stop this and write anything down, I would do so. You can go and play this back as many times as you need to as well. So name the circle and identify a radius. This would be circle E, because E is in the center. And then a radius, we actually have two different radii. We have E to B. Let me get the laser pointer. That would be E to B or E to D. Identify a chord and a diameter of this circle. So there's actually 3 different chords and 2 different diameters. The different chords are from X to Z, W to Y, and W to Z. And then the radii, the diameters are these right here, going through the center. Pretty simple. This is circle F, radius Fn. Not a chord, that would be the radius again, Fn. Radius and diameter, so the radius is half the diameter, or diameter is twice the radius. So we can know that radius half the diameter twice the radius. And when we did this in class, these were all things that you were all pretty familiar with. These are things that aren't new, they're not different things. So if I have, for example, a diameter of 21, my radius is going to be half that, 10.5. If I have a diameter of 26, radius is going to be 13. So hopefully this is all jogging your memory, you're remembering all this stuff. It was pretty easy when we did it before, but I just want to make sure you have these in case you need it. Honors, we talked about all these pieces. On level, really kind of focused right here on concentric circles. They're coplanar circles that have the same center. Coplanar circles that have the same center. So, for example, we wouldn't call these two circles concentric. We'll call that circle A, and then we'll do another circle. This one we'll call it circle Z. A and Z are not concentric because they don't share a same center. They don't share the same center, so they're not concentric. They are overlapping and part of each other, but they are not concentric circles. The diameter, this is a great problem. We've talked about this one before. I will go into this one. I think this is a pretty good problem to sort of look at and sort of see. Okay, we have 1 and then kind of 2. These are not to scale, as always. We all know Mr. Goodrow's drawings are never to scale. We have a couple things. We have X here. We have Y, Z, and W. So a couple of things we know. We know X is, let's go to the big screen. We know X is 22 units. The diameter of X is 22 units, 22 long. I don't know inches, centimeters, doesn't matter at this point. All we need to know is that it's 22. And the Y, this diameter, is 16 units long. Lastly, we're given one piece of information, and that is this is 5 units from here to here. So that little gap right there. The reason this matters is because we're given the diameters, but we're not given the radii. So if I know this is 22 units long, then I know this right here is 11 units long. From X to Z is 11 units long. Similarly, I know W to Y, let's mark it up here so we're not kind of overlapping. We know this is 8 units long. So let's redraw this kind of over here so we have a little bit of clarity, something like this. So I know this is 11 units long. I know this is 8 units long. So how long is this whole thing? Well, we actually counted this space twice. We counted that space in the 11 and the 8, and that one, that is 5 long. So to find this, all I need to do is 11 plus 8 minus 5. 11 plus 8, 19 minus 5. So it is 14 units long. 14 units long. Once again, we had our diagram. We were given these diameters. As you can see, we were given those diameters. Those helped us find the radii. And then once we had all that information, we kind of put it all together in just finding how long it is. So 14 units long. All of this are on the notes. These are all in Schoology. As always, we get there. This is 14 units. So I encourage you to take something like this and try it out on your own. Pause the video, draw your own diagram, and give it a shot. You do not have to wait for me. If I'm going too fast or too slow, you can always pause the video and give it a try on your own. So I'm going to do this as well, show you how it is done. So we have this. We need a bunch of circles. We need a big circle here. This will be our circle A. We go all the way to the edge. We have a circle C, kind of right here, or circle D, I mean. Okay, and then we kind of have a point here that's going to use this and this. Okay. This is not perfect, but let's give it a shot. Okay. So this is what we have. We have a couple things told to us. We're given this diagram, but we're also given other pieces of information. So let's see what our other pieces of information are. Well, we're given that D, B, and A are 4, 9, and 18 inches respectively. So the diameter of D, diameter of B, and the diameter of A are 4, 9, 18 respectively. So what that means is 4 matches with D, 9 matches with B, and 18 matches with A. I actually don't need all of these, but it's good that I have them. It's good that I have more information than I need, because that lets me know I can come in here and say, well, I have circle A. I know that this diameter is 18, what is it, inches? I get inches. Yeah, 18 inches. So I know the radius of it is 9 inches. Well, it happens to be A to D is my radius. So that is 9 inches. Once again, I'll draw a simplified version down here without the circles. So I know this line right here is 9 inches. Great. So what I want to find is, if we look back at the problem, we want to find A to C. That's our last line. We want to find A to C. We want something close to this distance. This distance, this is C, this is B. I know the whole thing is 9 inches. So I know my answer is going to be less than 9 inches. If I can find this and this, I can add them together, that'll work. If I can find the whole thing and take away this, that'll work too. I actually have the whole thing, and I do know D to C. I know my diameter of D is 4, which tells me my radius is 2 inches. I know my radius of D is 2 inches right there. So the D to C is 2 inches. That means A to C, all I have to do is take 9 inches, take away 2 inches, and I get 7 inches. That's my final answer. So this whole problem, all it's doing is saying, can you take these different diameters and cut them up into half so you have the different radii? We didn't end up using the circle B's diameter, but we could have put that in here and known a little bit more. So here are your options. Your options were 3, 5, 7, and 9. We found that by solving it, got 7. Circumference. We have circumference. We need to know this equation. Circumference is pi d or 2 pi r. Pi d or 2 pi r. If we wanted to have this question, it's a series of crop circles was discovered in Alberta, Canada on September 4th. The largest of the 3 circles had a radius of 30 feet. Find its circumference. In order to find the circumference, all we're going to do is either take, if we're given a radius, we're going to double it. If we're given diameter, we don't have to do anything. In this case, we need to double 30 to get 60, and our answer will be 60 pi. 60 pi is like an exact answer. That way we don't have to cut off decimals, because hopefully you remember that pi has an infinite number of decimals. So if we start multiplying things by pi, we're going to have to simplify it. If we did multiply it, we get about 18.5. about 18.5. We'll normally take this answer, 60 pi, because that way if we don't have our calculator, we can still do that. We have something like this. It has a diameter of 120 feet. Find the circumference. I'll do this one on the little paper. We have a diameter of 120 feet. And we know our circumference equals pi d or 2 pi r. Well, which one am I going to use? Well, I'm given the diameter. That is the full length, so I want this one. My circumference, to be perfectly accurate, is 120 pi. That is an exact answer, and most times that's the one I'm looking for. 120 pi. If we wanted to approximate it, what we would need is a calculator. We're not going to multiply it by 3.14 or 3.1415. On your calculator, this is a TI calculator, but I think most other ones do. I think your iPhone even has this feature. There's a pi button. If you're looking on the TI, it is right here where the caret is. We have to press second and then that. So if I wanted to find 120 pi, 120 times second pi, and I get, it's probably tough to see, so I'll write it out, our approximate answer, and it's approximate because pi has an infinite number of decimals that we have to account for. 376.99. And we're in feet, so that is that. So that, even 377, I'll take that if you are on a test, or if we're even lucky enough to get back into class and you have a test on this, that's a perfectly fine answer. These three are all equally valid. So let's go back to our options. We have 377.0, 392.5, and let me move the other piece instead to over here. 392.5, 408.3, 422.1. We got 377.0. And great, turned out to work out. Find the diameter and the radius of the circle to the nearest 100th. This one looks like it is giving out, or something is not correct. What it's saying is we're given our circumference. So it's a similar problem to this, except we are given our circumference. So if circumference equals 65.4, for example, if we're given that, we know we can still use these pieces, and it's looking for the radius. I know 65.4 is 2 pi r, and that's just using our same equation. Instead of doing it on this side, we're going to do it on this side of the equation. And I'll just divide by 2 pi. Once again, I need to use the pi button because it's more exact. It's different than multiplying by 0.3 or 0.3 repeating for a third. It's just going to give you a lot more precision. Divided by 2 and a pi symbol. Actually, I'll put those in parentheses just to be safe. And I get r is about equal to 10.4. We always do like somewhere between 1 and 4 decimal places. We don't want to do like 7. We can do an infinite amount, but we have not an infinite amount of paper and markers. So I got my radius to be about 10.4. Find the radius of a circle to a nearest 100th. If its circumference is 16.8, this would be a good time to pause the video and give it a shot, especially if you are not remembering this exactly, but you want to give it to see what how much you remember. The answer is 2.67. Find the exact circumference of K. This is a kind of question that I expect from the honors, so on level. Still good for you to know this, but this will not be something I will ask you guys. We have exact circumference of circle K. We know that this right here and this right here are both radii. This is the diameter here. So these legs of this triangle are the same. We don't really know what they are, but if the legs are going to be the same, that should tell us that what kind of triangle this is. So if I have two legs that are the exact same, let's call them, I don't know, L. And I know this is 3 root 2. Is it 3 root 2? Yeah. It's 3 root 2. All I have, if I know this, then I know this is a special right triangle. I have a couple options. I can do trigonometry with my 45 degrees. I can go back to the chapter with our relationships and see what this is. But basically I know 3 root 2 is going to equal L root 2 because our hypotenuse is L root 2. So if I have this, and all it really can do, I can just cover that up and see, well, if I just add a root 2 to that, I know L has to be 3. But it's not just L. In this case, if you look back again at the slide, L is our radius. So our radius is 3, which helps us know, 1 second as we load. So this tells us that our circle has a radius of 3. This is the same circle. So to find that circumference, all I have to do is 3 times 2 times pi, and that's going to be 6 pi, or a little more than 18 to be specific. It would be 6 and pi 18.85. Once again, we had this triangle in here, and we're given 3 root 2. We knew that since they're radii, that's how we knew that these match right here. Because to go from the center to any point on the circle is the same distance. So we had those being the same length. And we get this. Hopefully that makes sense and how I found that. Find the exact circumference. You can give that a try and find 10 root 2. All right, that is 10-1. Hopefully that makes sense. You have those slides available to you. There are worksheets for each section that I'm going to put on Schoology after we are supposed to go over them. So you do have a worksheet on this. It should be in its own Chapter 10 worksheet folder. Once again, I will be around to answer questions during certain class times and office hours, but please, please, please don't hesitate to reach out to me. I want to make sure this is a simple process for us all. Yeah, I hope this made some sense and you feel okay going into 10-2. Thank you.